Waki.
Ay, Waki! You submit mo. Good morning, everyone. Today we're going to do the experiment number 10. This is the field density test by sandstone replacement method. And for our objective is to determine the density and the unit weight of the obtained soil sample using the sand cone method, and to evaluate if the soil sample density and the unit weight correspond to relevant standard and specification for the intended use.
For the materials, we'll be using the sand cone apparatus, which includes the container, the conical outlet, and the base plate. And we'll also need a density cylinder and also for the container for the soil and a ruler.
For the lab equipment, we will need this soil dry oven. Another lab equipment that we will use is this weighing scale.
Now we're going to weigh the apparatus.
We will now fill the container with sand. We will now weigh the mass of the sand, container, and the cone. We will now weigh it again after the procedure.
Yay!
For the second trial, we will now weigh it again.
Now we're gonna weigh again.
We will now set the base plate on uneven ground.
We will now dig a hole through the base plate.
We now weigh the soil sample.
The results obtained from the field density test using the sand cone replacement method provided essential data for analyzing the compaction and density of the soil sample. The bulk density of the sand was determined to be 1.458 grams per centimeter cube, which was used to calculate the volume of the test hole, measured at 1,934.15 centimeters cubed. The bulk density of the soil was found to be 1,321.85 grams per centimeter cubed, while the dry density of the soil was calculated at 1.46 grams per centimeter cubed, considering a moisture content of 15.625%. The bulk and dry densities of the soil are crucial factors in construction and engineering as they determine the soil's ability to support loads and resist settlement. A higher dry density generally indicates a well-compacted soil, which is preferred for construction projects to ensure structural stability.
The sand cone replacement method was successfully used to determine the in-place density and unit weight of soil, yielding a dry density of 1.46 grams per cubic meter. This value suggests that the soil has an acceptable level of compaction, which is important for ensuring soil stability and structural integrity in construction projects. The result emphasized the importance of proper soil compaction as it affects the soil's strength, load-bearing capacity, and overall performance in construction applications. The experiment followed ASTM standards, ensuring that the methodology was precise and reliable. However, to further improve accuracy, it is recommended to multiple tests can be conducted across different locations within the site. This would help account for any variability in soil properties and ensure a more comprehensive assessment. Additionally, comparing the sand cone method with other field densities tests could help validate the findings and provide a broader perspective on soil compaction characteristics. In conclusion, the sand cone replacement method remains a valuable tool for field density testing, provided that proper calibration, standardized procedures, and careful handling are observed. The results obtained in this experiment contribute to a better understanding of soil compaction and its implications for construction projects, reinforcing the importance of field density in engineering and geotechnical applications.